sorry. So the height at the bottom is going to be 0,
Okay.
but as it goes up the ramp, you're absolutely gaining height.
Okay.
So your height is always measured vertically.
Okay.
Cool? So even though you're still on a surface, you're still going up. Okay, so number 7, you've got this ramp. It tells us that it's 5 meters long and that it's inclined at 20 degrees. So if you do the trig real quick and find the height over here, it turns out to be 1.71 meters. Okay, everybody cool with how I did that? Just, SOHCAHTOA. All right, and so what we know is the box has a mass of 100 kilograms. Roy pushes this thing with a force of 825 newtons up to the top of the ramp. All right, so at the bottom of the ramp, I know my height is 0 and my velocity is 0. The question wants to know when we get to the top of the ramp, what's the velocity, right? Okay, well, again, based on this little trig, we know that at the top, the height is 1.71 meters. All right, so I've already started grading the target checks from first hour. The people who are struggling are the people who are not taking the time to do this process right here. Okay? I cannot stress enough how important it is that you take the time to do this. Okay? The other thing I will say that I've seen people struggling with a little bit is, as you solve the problems, you need to pick a point to be a height of 0. All right? And usually it's fairly obvious. In this one, obviously, the bottom of the ramp is a height of 0, right? But once you pick that, wherever you choose your height to be 0, stick with it. Okay? And that way, anytime you calculate a height, you know that you're measuring the height from that point that you chose to be 0. So if you choose the tabletop to be a height of 0, and you calculate height, then you're measuring the height from the tabletop. If you choose the ground to be a height of 0, and you calculate height, then you're measuring the height from the ground. Does that make sense? Okay, so any problems with what I've done here? All right, so now let's talk energy. At the bottom, there's no height, no velocity. That means my total energy is going to be 0, right? I guess this is misleading. I probably shouldn't have written that way. This is actually GPE is 0, KE is 0, and you add those together to get that your total energy is 0. Cool? All right, over here, if our height is 1.71, that's going to correspond to some height, or some GPE rather. So the GPE here at the top, it ends up being like 1666-ish. Okay? Now, since I don't know my velocity, I can't find my kinetic energy. So I'm kind of stuck there, right? Is everybody okay up to there? Yeah, that's fine.
I don't know. I saw this in a different way again and got the same thing.
Okay, there's different ways of doing it. Let me
Okay.
finish it this way, and then I'll ask you what you did. Is that cool?
Okay.
Okay, so is everybody okay so far? All right, so now my question is this. What do I know about my total energy? Is it staying constant? It's changing, right? So having established that my total energy is changing, what should I do?
It's changing.
Oh, total energy is changing, guys. So what should we do?
So basically,
Find the work, right? More specifically, find the work of non-conservative forces, right? Does that make sense? Okay. So I can't do this equation because I don't know my TE final, right? But I think we can do the top equation. The only non-conservative force here is Roy, right? Okay, so let's do this. Let's find the work from Roy. Well, the work from Roy is his force. Oh, shoot, I didn't give myself enough room. We'll do it down here. So the work of Roy is the force of Roy times the displacement. What do I use for the displacement, you guys? 5 meters times the cosine of 20, is that right? No, right? That's the common mistake people always make. Okay, look at the drawing. My force is up the ramp. My displacement is up the ramp. What's the angle between those two vectors? 0, right? Okay, so times the cosine of 0, which is 1. So this is it. So just multiply this out, and it gives you 41.25, I think. I did that in my head, but I think that's right. Follow? Yes, sir?
Wait, never mind, sorry.
You sure?
Yeah.
Okay, are there any other non-conservative forces in part A? I think that's it, isn't it? Because it says it's frictionless for part A, right? Okay, so what do I do with this number, you guys?
Well, wait, no.
Close. I want you to add one word there. She just said that's her total energy. So it's the change in total energy, which in this problem amounts to the same thing since you're starting at 0, right? But I want to make sure you guys understand, this number tells us the change in total energy. So we started at 0 plus this, you end up at 41.25. Cool?
What about the force of gravity?
We don't need to worry about gravity because we're only worried about non-conservative forces.
Okay. But on the problem, I thought that it, like, I don't know, I don't have my sheet out.
Okay. Yeah, dig it out. It shouldn't, I mean, there is gravity for sure, but solving it this way, we don't need to worry about it.
Okay.
All right, so is everybody good with what I did here? I know my total energy, I know my GPE, so now I can subtract to find my KE, and then use that to find the velocity, right? Cool? Problems? All right, I'll do part B in a second. Before I do Weston real quick, did you do kind of what Ethan's talking about, deal with the force of gravity? Or no?
Oh,
There is another way to do this.
so he had force 1825, and since he's inclined, I used trig to find force parallel, subtract the 2, use work equation, got that, and then took square root of that with 7 years.
Okay, so if you want to go the net force route, girls, can you guys? If you want to go the net force route, you can do that. So you'd go, all right, well, my net force here is going to be the force Roy plus FG parallel, right? So what did that give you, Weston?
Wait. Oh, it gave me the, when you subtract,
Yeah.
oh, 489.82.
489.82.
Yeah.
So then what you can do is you can find the net work by multiplying that force by your distance. Okay? So do you remember what that gave you?
2449.1. I don't know how to read those.
That's okay. All right, so that gives you, but what does this represent, you guys? That's your net work. That's no longer your change in total energy.
It's the change in kinetic.
It's the change in kinetic energy. Okay, so that works too. Because you know you started with no kinetic energy, so this is how much kinetic energy you gained. So that's another way of doing it.
So then, how would so then would you subtract his GPE from that?
You don't need to. That's what I'm saying is that, not by definition, but one of the rules we learned is that if you calculate net work, that gives you the change in kinetic energy. So to do it that way, you don't even deal with GPE. You just, because it doesn't matter, because it's sort of subtracted out already by dealing with gravity here. Does that make a little bit of sense? Okay, everybody good up to there? Yeah?
I got like a general question. So if it was on if it was on a flat surface and you were pushing with 20 degrees, then would you use cosine?
Correct, yeah. Yeah, so that theta that's in this equation over here that you can't see because you got a janky seat is the angle between the force vector and the displacement vector.
Okay. And could you also just find like the horizontal force? That would be
Yes.
the same thing?
Yeah.
Oh.
Yeah. All right, are we good? All right, so part B says something about in the real world there's friction, right? Let's see. Suppose the velocity at the top is only 4 meters a second. Calculate the force of friction. So for part B, here's what we're going to do. We're going to draw our box. Here's what we know. We know at the bottom the height is 0, velocity is 0, so your total energy at the bottom is 0, right? Okay. Up at the top, we know the height is 1.71 meters and the velocity is 4 meters a second, right? Everybody good up to there? Okay, so if you figure it out up here, your GPE ends up being pretty close to this. Your KE is half the mass, so 50 times 16, what, 800, is that right? Cool? All right, and so that means the total energy by the time we get to the top of the ramp is this. Cool? So, we've got a change in total energy. That means the work done by our non-conservative forces is this, 2466 minus 0. And we had figured out in the last problem that the work that Roy did was 4125, thank you. All right, so look, you guys, if our total work done by non-conservative forces is this much, and Roy did this much work, then somewhere we've lost some energy, we've lost some worth, right? Where? How is it possible that Roy gave this thing 4,000 joules of energy, but we only gained 2,000? What do you got, AJ? Yeah, friction, right? So this has to be the sum of the work of Roy and the work of friction, right? So these two have to add up to this. Follow? So the work of friction must be negative, whatever that difference is, right? Anybody have that handy? No. It's bigger than that. 2466 minus 4125. 1659. Does that make sense, you guys? You just throwing out random numbers? 5,682! All right, are we good?
I did it a different way too, so I was just thinking that.
I got that, yeah. All right, so is everybody good with this? All right, and then we can divide that by 8 meters to get the force of friction, right? And then you're done. Or is it 8 meters? How long was the ramp? 5 meters. Sorry, I said 8. 5 meters. What's wrong, Meredith? You're making a scrimpy with the hell did you do face?
Divided by 8 meters.
Gotcha, yeah. Okay, so first of all, it's not 8, it's 5, because that's how long the ramp is. So remember, work in energy. Let me try that again. Work is a change in energy. It's caused by force. Okay? The equation that relates those two is this. The amount of work done by a force is equal to the magnitude of the force times the displacement times the cosine of the angle between those two things. And there's no angle, right? Because, do you see that now? So yeah, so we know this guy, we know the displacement, so find the force. Cool? Yeah, listen.
When you have the velocity from part A, and you do kinetic energy equals 3.5 m/100 e squared, which is 16, and you get 800. Somehow I got one. Oh, I think I. I don't know what I wrote. I don't know what I wrote. I'm trying to make sense. The document to that stuff that.
You have a question?
I guess.
Why don't I come look at it before we get started on the target check, all right? Oh, is it still recording?
Yeah.
Hey, everybody.